So here's a compound interest formula problem. Compound interest formula looks like A equals the principal, 1 plus the rate divided by n, and then n times t is the exponent. The t is how many years the money's going to be in the account. The n is given by this information. How many times a year is interest paid? So because of this, quarterly, n is 4. So we would have invest $800 at 9%, compounded quarterly. Okay, there's the first sentence, translated into math. Now, how long will it take, in other words, solve for t, for the amount to double? Well, if you double $800, that's $1,600. So the amount A is $1,600 after how many years? For this, we need to first isolate the base by dividing both sides by 800. If you divide this by 800, it's going to give you 2. That's essentially the double part that was in the problem. And then in order to solve for an exponent up here, the only way to do that is use logarithms. Well, that's not the only way, but for up through pre-calculus, that's the only way. In calculus, you'll have more ways. So then, take this exponent of 4t, bring it down in front of the natural log, and make it multiplication. With these decimals in here, do not just combine them and write 1 point something as an estimate. Just leave it like this to be as accurate as possible. We'll just type it in the calculator just like that. All right, now to solve for this t, we then need to get rid of the 4 by dividing, get rid of the natural log by dividing. So the t will stay here, but then we're going to divide both sides by the 4 and the natural log of those decimals. Okay, then let's find out how much that equals. So we've got the natural log of 2 divided by, and then this needs to be in parentheses, 4, and the natural log of 1 plus 0.09 divided by 4. 7788. So just over 7 3/4 years until you can turn $800 into $1,600.